Welcome to today's tutorial. Let's get started. Let's have a look at our agenda for today. Today we are looking at converting your register-based logic program to variable-based in Cscape. We'll start with a quick review of the advantages of variable-based programming. Then we'll describe how register to variable conversion works. We'll give you some tips and tricks while you're going through the workflow. Then we'll demonstrate some example conversions in Cscape so you can see exactly how the process works. Let's start with the advantages of variable-based programming. Remember, when using register-based programming, all the variables we put in our programming have to be specifically mapped to areas in memory. So that's an extra process you have to go through that you don't have to go through with variable-based ladder. With variable-based, you just name your variable and use it. There are a few exceptions where you do have to map variables, but those are limited to things like real-world I/O points and maybe data that can be made available over Modbus, so a SCADA package or something like that can have access to it. Also, variable-based logic supports modern features like variable arrays, data structures, and user-defined function blocks. Now let's talk about how this register variable conversion works in Cscape. You start by loading your original register-based program or a copy of that program. Then, as you go through the process, your original program is going to be renamed, and variables are going to be created for every element in your program. The memory mapping that you established in the register-based program will remain. It's not changed or deleted. Then, you'll save the converted program after that process is complete. Then, in the end, the converted program can now be modified and edited as a variable-based program. How does Cscape decide how to create variables where there maybe were none before in the register-based approach? Well, first of all, as most of you know, register-based logic does allow you to name certain variables. It's just called I/O names. So any I/O names that were established in the original program are maintained, and those I/O names are carried on as variables. Any system bits or system variables that have standard names are just named with their standard names as variables. For any registers that aren't named, Cscape will just give a variable name based on the register name. So if R1 wasn't given an I/O name originally in the register-based program, it'll be called var underscore R1 as a variable in the converted version. Registers used for ASCII functions are stored in bytes, and you can have 2 characters per 16-bit register. When those ASCII functions are converted, they are converted to byte-type variable arrays. Now again, as mentioned, all the memory mapping that was done in the original register-based program is maintained. Cscape doesn't delete or remap it. Then, after a conversion, if you ever need to add variables to your program, you don't have to do the actual memory mapping. Even though all those existing variables were previously memory mapped, you can just add variables like you normally would with variable-based logic. Some exceptions to note here is if they're mapped to an I/O point or if they're available via Modbus. Now let's look at some tips and tricks we think you should perform before you convert your program. First, you should familiarize yourself again with your code. This could be code that you haven't touched in a while, or maybe that you didn't write, so it's always a good idea before you work on any program, even if you're just doing this conversion, to refamiliarize yourself with how it was written and how it works. Before you convert the program, it's also a good time to clean up the documentation. If there are registers that weren't named, or the names weren't very descriptive, or there were not many comments, it's a good time to clean up this documentation. Then finally, the third thing you should always do before converting is to retest your program again, and to make sure everything in the program is working before the conversion. Now let's look at the conversion process itself before we demonstrate it in Cscape. Again, we start by opening up a copy of the original program in Cscape from the Program Navigator. Then you right-click on the program name, and then you'll see near the bottom, Convert to Variable-Based CSP. You select that, then Cscape will bring up a process window. You'll press Start, and then it's going to prompt you to save the file under a new name. Now, following this workflow, you already opened it up as a copy, but it's still a good idea to give it a new name. By default, Cscape is going to add a suffix of underscore converted to the end of the original file name before the .csp. So then that becomes saved, and the status dialog opens up, and you can follow along as Cscape goes through the process and reports exactly what stage it's in as it does the conversion. Then, at the very end, it will report what the original size of the file was, and then what the resulting file size is after the conversion. One thing you'll notice, especially if you're starting with a really small program, is you'll see that the file size gets bigger. Also keep in mind that in a somewhat recent firmware version about a year ago, we were able to double the capacity of the program files in all the OCS controllers. So even if your capacity went way up and you're worried that it may have exceeded the capacity of your OCS, it's more than likely that just by upgrading the firmware in your OCS that problem will go away. Also, if you're talking about a large program, it's only going to add a few thousand bytes to that large program. So for our large programs, as a percentage basis, it's not going to make much of a difference. Now let's demonstrate a few example conversions. Let's start with a large program. Here I have a program called Pump Control Triplex. This is a register-based program. Again, we recommend that you start by familiarizing yourself with your program, as well as going through and cleaning up any documentation, such as going through the I/O names and making sure all the names make sense. And if there are a lot of undocumented registers that aren't named, you should consider renaming those as well. Then of course you should test your program, but for the purpose of this demonstration I'm just going to go through the conversion process and show you what it looks like. As you can see here, this is a program with a few main loops and several subroutines. It's a reasonable size, and if we do a check on the size here, you can see it's about 10 kilobytes of ladder logic. So it's not too big, but it's a decent sized program. So now let's do the conversion. So first we highlight the name of the program in the project navigator, right click and select convert to variable based. Then we press the start button and it immediately asks us to save it. So I'll go over to my programs to convert folder and I'll use the name it picture me with the added underscore converted suffix at the end. I'll hit save and now it's going to go through the process, as you can see, and documents all the different conversions that it's doing. And after about 10 or 11 seconds that process is complete. So let's look at what the size changes were. Before conversion it was a little over 10 kilobytes, and after conversion it's still just a little over 10 kilobytes, so it only got bigger by a few bytes. So that won't be any issue when it comes to downloading the program. So now once I hit save, this is now a fully variable based program. I can now examine all the variables and just see what the conversion looks like. So I'll open the program variable window. Then I'll expand the global variables area and stretch out the variable names, memory locations, etc. So here are my global variables. So what do we see here? Well, first of all, we can see as we work our way down through that we have plenty of variable names that were obviously I/O names before. We also have some variables that had no name before, like T3 and T4, and you can tell that because of the var underscore type prefix. The other thing you'll notice is that in the memory column here, everything is still memory mapped, and that's because Cscape does not delete the existing memory map that was created in the register-based program. It leaves it intact. But if we were to add additional variables to this program, anytime we add a variable again, we only need to memory map it if it meets one of our exceptions, which is if it has to be mapped to real-world I/O or if it's been shared via Modbus, etc. As you can see in this list of variables, it's a fairly extensive program. So we can go through them in this order, or we can even click on the name column and then it puts them all in alphabetical order, and then we can examine them that way. So it's created all these variables, and if we go in and take a quick look at some of the code, we can see that it truly is variable based code now, because we don't have any register references in the logic along with all the variable names. So our conversion is complete. And that's an example of a fairly sizable program that we've converted using the built-in conversion utility. Next, let's look at another example where the program is smaller. Here we also made sure that all the documentation was cleaned up and that all the variables were named properly, and tested the program to make sure it's running properly. This is a register-based program based on the XL4 OCS all-in-one controller. You can see we have logic here written in the analog scale section of the main loop. We also have a subroutine called cal 3 point, and you can see it's obviously a register-based program from the way everything looks. If we look at the I/O names, you'll see we've named a lot of the variables. So basically all the variables are named here. Then if we look at sizes, we can see this one is a bit smaller. It's about 6,500 bytes of logic. So let's go through the process for this program. Again, I right click on the name, hit convert to variable based CSP, and I'll hit the start button. And then I'll save it under a new name. And in this case, I'm happy with the name it's giving me, which is just adding an underscore converted to the end. And I'll hit save, and then Cscape will carry out that conversion process. And as you can see, that completed very fast. For this program, you'll notice that it had a significant increase in size. So this one went from 6,500 bytes to about 56,000 bytes. So that's a big increase, but again, it's not a big program. We're still at less than 3% capacity for the OCS. So generally, you don't have anything to worry about when you convert your programs. And if it does get larger than your OCS can handle, then probably just a firmware update on the OCS will open up that extra space if you haven't completed that already. Now let's look at the variables. So under global variables here, I'll start scrolling our way down, and we can see we have variable names for everything, and everything is still memory mapped. And again, we don't see any of those var underscore type variable names here because everything was given a name and documented before we started. That concludes our demonstration for today. Thank you for joining us for today's tutorial, and the Q&A session will begin shortly.
Okay, hopefully that was of use to you this morning, and all back for our first webinar back. So next week we have using 2 Ethernet ports on the new XL Prime units. So if you haven't already registered for that, the link is on the webinar page on the website under support. Failing that, I'm not seeing any questions. So thank you all for joining us this morning, and we do hope to see you again next week.